video we'll discuss about simplifying radicals, and before that let's see what are the parameters of an expression is in simple radical form. So the first one, it has the radicand of an nth root contains no nth power of s factors. The second one, the index is as low as possible, and the last one is there are no radicals in the denominator. So let's discuss one by one. The first one, the radicand of the nth root contains no nth powers as factors. So let me just put this as simple as this. If I have square root of 288, and if I want to simplify it, first I want to find all the factors of 288. Therefore, I will use the factor 3, and then just using the factor 3 that you are familiar with. And with this, we can see that, yes, to continue, I will find the factors and to find if the radicand has exponents or has powers with the exponents is greater than the root index. So if there is, it means we need to simplify it. So based on this factor 3, I have 2 to the 1, 2, 3, 4, 5, fifth power multiplied by 3 square. As you can see, because this is a square root, the root index is 2. So I have powers in my radicand with 5 and 2 as the exponents. Therefore, it is greater than the root index. It's still not the simplest form. I have to simplify it. How? So let me just show you this approach that I put all the factors, and then because this is a square root, I find all the pairs. This is the first pair, the second pair, third pair, and then if I have the pairs, so they can get out of the radicals. So yeah, you must have familiar with this. You must have been familiar with this. So this is the final answer: 12 to the times square root of 2. So let's go to the second example. Okay, this is the fourth root. Okay, the root index is 4, so with the factor 3, but I skip that part. In the end, I find that all the factors is 2 to the 5th power multiplied by 3. That means as the radicand, I have a power with exponents is greater than the root index. 5 is greater than 4. It means I still can simplify these radicals. So let me just put it this way, because I have 2 multiplied 5 times, and this is a fourth root. It means I can extract 2 out if I have 2 4 factors. Okay, so 2 you can get out of the radical sign. So what is being left as the radicand is 2 times 3. So this is the final, the simplest form of fourth root of 96. So this is the first requirements, and now let's speak about the second parameter. The root index is as low as possible. What does it mean? So I give you 2 examples. I hope these examples can really give you an insight. So the fourth root of 9, if I put it into the factors form, actually I don't have any issues, because 3 square, the power, the exponent is lesser than the root index. It means it has fulfilled the first requirements. But if I convert into the exponent, it will become 3 to the power of 2/4, which I can simplify it into 3 to the power of half. Therefore, I still can simplify the radical by putting a lesser root index, which is 2. So it is square root of 3. Now the second one. This is the 8th root of 64. So 64 is 2 to the 6th power. 6 is less than 8. It means it has fulfilled the first requirements. But if I put it into the exponents form, I still can simplify it into 3/4. Therefore, if I convert back to the radical form, it will be 4th root of 2 cubes. So it is 4th root of 8. So this is the simplest form, since I can make it into a radical with lesser root index. So now here's the big one, the third one. There are no radicals in the denominator. So there are so many cases. Let's start with the basic one. I give you 3 examples here with radicals in the denominator. The first one, 2 over square root of 6, which is 6 to the half power. If I change it into exponent, Keep in mind that if we have radicals, it means we have an exponent, we have a power with fraction exponent. So let's get rid of the fraction exponent in the denominator. I use this 6 to the half power, so I can have the denominator has a power with integer exponent. So in the end, I can simplify it into 1/3 times square root of 6, or square root of 6 over 3. So we have get rid of the radicals in the denominator. How about the second one? So if I convert into exponent, this is 3 to the power of 2/3. So if I want to get rid of the fraction exponents in the denominator, I need to multiply it by 3 to the 1/3 power on both sides. I mean on the numerator and denominator. So in the end, I can have the denominator without any fraction exponents, right? So we have gotten rid the radicals, and we have this as the simplest form. And this is the last one. 7 over, this one is 7 to the power of 2 over 4. Well, I can simplify the exponents in the denominator, so it is 7 over 7 to the power of half. And since it is still a fraction exponents in the denominator, I need to multiply it by 7 to the power of half and over 7 to the power of half. And I can simplify it because the denominator, we can see it's gone, the radical is gone. So this is the simplest form. That's how you get rid the radicals in the denominator. Remember, this is expressions, you can only multiply it by 1. So the second cases is if look at the denominator, it's not as simple as like a radical, it is a sum. So the basic is using the conjugate. Okay, if you remember, a plus b times a minus b is a square minus b square. So a minus b is the conjugate of a plus b, and vice versa. A plus b is the conjugate of a minus b. So if I have, for example, square root of 7 plus square root of 3, if I multiply it with its conjugate, the conjugate of this one is square root of 7 minus square root of 3, the conjugate. So if I multiply it, I can have square root of 7 square minus square root of 3 square. So it will become 7 minus 3, it will be 4. So with this approach, let's do the same thing with this fraction. Because it has radicals in the denominator, let us get rid of it by multiplied with the conjugate of the denominator. So it is 5 minus square root of 3 over 5 minus square root of 3. So in the end, you just need to multiply both the numerator and multiply the denominator, but the denominator becomes 25 since it's 5 square minus 3. So you have gotten rid the radicals in the denominator. So yeah, by the simple algebra, and you can see that we can still cancel it, simplify it. So the simplest form is 5 minus square root of 3 over 11. And how about the second one? Okay, still, you don't have to pay attention with the numerator because we allow the numerator has radicals. So the thing is, we need to get rid the radicals from the denominator. So multiply it by the conjugate of the denominator. It will be square root of 7 plus square root of 3, square root of 7 plus square root of 3. So the rest will be the same, just multiply the numerator, square root of 3, multiplied by this, and then over. Now, square root of 7 square is 7, and 7 minus 3. So it's simple as 7 minus 3. In the end, I will distribute the square root of 3 into square root of 7 and square root of 3. You get the idea. And in the end, just a simple algebra, and I can have this as the simplest form. So there you are. Okay, so now let's go to the next level. How about this one? Okay, we have 3 terms in the denominator before we have 2 terms. So in this case, we need to associate, we need to choose. Do we have to associate the first 2 terms, or do we have to associate the last 2 terms? But for this one, let me give you hints separate the radicals. So we choose to associate the first two terms because we need to separate the radicals. What is the why? In the end, if after you have done so many practice, you will know why. Okay, it will make less complicated. So when I associate it, I put the parenthesis, and the conjugate of the denominator becomes the first two terms plus the last term. You can see. So the conjugate will be the first terms plus the last term because the denominator has the first two terms minus the last term. So after this is quite complicated. As you can see, we are dealing with quite complicated polynomials. So let me just show you step by step. We multiply the numerator, and then the thing about the denominator, it becomes the first two terms being squared, 2 plus square root of 3 squared minus square root of 7 squared, which is 7, right? So let's just, before we go further, let's simplify it. I want to distribute 12, but before that, let me just simplify it inside the parenthesis, and then over, and then let me square 2 plus square root of 3, which is, I'm sorry, let me just fix the line here. It is 4 plus 4 square root of 3 plus 3 minus 7. So in the end, I need to distribute 12 into each terms, 2 square root of 3 and square root of 7. So in the end, we have this. Okay, let me just go continue. And then over, let me just, I can safely eliminate the parentheses there and then change the order of the addends and subtrahend, and I can have this. Let's just simplify it. I cannot simplify the numerator, so let's just keep it that way. 12 square root of 12 square root of 3 plus 12 square root of 7, and the denominator, I have 4 square root of 3 minus, no, none. So it's gone. So in the end, I still have radicals in the denominator, so I need to multiply it by square root of 3 over square root of 3. So I distribute square root of 3 into all of the 3 terms in the numerator. So I believe you get the idea. It's hard work here. Bear with me. Over, so it becomes 4 times 3 because square root of 3 multiplied by square root of 3 is 3. So the last will be just simplified, and as you can see, it can become the last statement or the final answer because we have already simplified. We have already eliminated the radicals in the denominator. Okay, but still I can simplify this. I factor out 12 out of the numerator, so it becomes like this, and I can cancel 12. So the final answer will be 2 square root of 3 plus 3 plus square root of 21. And this statement has fulfilled all the pre-requirements of simplest form of radicals. So let me go to the next examples. How about this one? Again, we have 3 terms in the denominator and 2 radicals. So let me just separate the radicals. So I don't want to associate the first 2 terms. I want to associate the last 2 terms. So again, you can associate the first 2 terms, but let me assure you it will be more complicated. So let me just associate. It becomes like this, right? So now let's multiply by the conjugate. So the conjugate will be the first term plus the last 2 terms. Okay, so keep in mind that you only change the please see how the conjugate works if we are dealing with 3 terms. Why I need to associate? So these 3 terms I can make it as if it is 2 terms, so I can decide how the conjugate works. So the rest is just simplifying. But keep in mind, when I multiply the denominator, it becomes 5 minus, in parentheses, square root of 3 minus 2 being squared. So in the end, I distribute the 12 into all of the three terms in the numerator, and then I will square that one. Okay, it becomes 3 minus 4 square root of 3 plus 4. So I will simplify the denominator first. Okay. As for the numerator, I cannot do anything with it. So let me just write it this way. I just copy it. But as you can see, the denominator, it still has a radical. So we still have to do something with it. But before that, let me just simplify it. This 4 square root of 3 plus minus 4. Okay. And let me just put it into simpler form for the denominator. Again, I cannot do anything with the numerator. I just copy it. So now the denominator becomes 4 square root of 3 minus 2. So I need to multiply it with the conjugate again of the denominator. So the conjugate is 4 square root of 3 plus 2 over 4 square root of 3 plus 2. Okay, again, this will be hard work because we multiplied a lot of terms here. So let me just put it this way so you can get the idea how it works, the multiplication on both numerator and denominator. But for the denominator, it becomes 4 times square root of 3 being squared minus 2 squared, which is 4. So the rest, I just need to show you the multiplication work. I have to multiply it one by one. So yeah, this is the result. Okay, 24, and then 48. And please bear with me, 48 times 3, and then 24 squared 3, and yeah, this one. Okay, over this one will be 16 times 3, which is 48. 48 minus 4. Okay, then let me just simplify it. Okay, I'll stop talking now. Let me simplify it. And here's the next one. Okay, this one is different. And let me review about this one. If I have 4 cube plus 5 cube, or 4 cube minus 5 cube, if I factor it, it becomes like that, right? Since I refer to the a cube plus b cube, it will be equals to a plus b multiplied by a square minus ab plus b squared. And so, yeah, the same with 4 minus 5 things. So if I put into 4 plus 5, I want to tweak it. It becomes 4 to the power of 1/3 being cubed. It's the same with 4, right? So it is plus 5 to the power of 1/3 being cubed. So if I factor them using the same rules as the above, it becomes 4 to the power of 1/3 plus 5 to the power of 1/3 multiplied by 4 to the power of 1/3 square plus, or minus, sorry, 4 to the power of 1/3 multiplied by 5 to the power of 1/3 plus 5 to the power of 1/3 being squared. I'm using the factoring method above. So when I convert into the radical form, I have cube root of 4 plus 5 in parentheses multiplied by open parentheses cube root of 4 square, which is 16, 4 square, 16, minus cube root of 4 times 5, which is 20, plus cube root of 5 square, which is 25. So if I multiply those factors, I will have a simple 4 plus 5. So in this new example, the thing is, I have cube roots in the denominator. So I cannot multiply it with its conjugate, of course. Why? Because it only works for square root. If I multiply by the conjugates, if you try it, you cannot get rid the radicals in the denominator. So it's not the method. Let's approach by the factoring of cubes. Okay, sum of cubes or difference of cubes. So let me just put it again into the exponents form. It is 2 to the power of 1/3 minus 3 to the power of 1/3, and I multiply it by the pair. If I factor, if you see above, I multiplied by 2 to the power of 1/3 being squared, plus 2 to the power of 1/3 times 3 to the power of 1/3, plus 3 to the power of 1/3 being squared. So that is the simplest one. So I have to multiply, I have to put the same in the denominator, since every expressions you can only multiply it by 1, right? So 1 is the ratio of two exact numbers or exact variables. So the result in the denominator, because I'm using the right pair, I just write down first the numerator into radical form. It is cube root of 4 plus cube root of 2 times 3, which is 6, plus cube root of 9. And the denominator, it becomes as simple as 2 minus 3. So we have gotten rid the radicals in the denominator. And because it is negative 1, I just divide all of the terms in the numerator by negative 1. So it becomes negative, negative, and negative. Yeah. So that's the final answer. As simple as that. If you can multiply with the right, not the conjugate, right pair. Okay. So the same thing. Try to review back quickly the factors of cube, sum of cube, and difference of cube. If I convert this example into exponents, it becomes 2 to the power of 1/3 square plus 2 to the power of 1/3 times 5 to the power of 1/3, and then plus 5 to the power of 1/3 being square. Okay, it's the same. But you can see the pattern here. If I multiply it by 2 to the power of 1/3 minus 5 to the power of 1/3, I can get rid the radicals in the denominator, because it is the right pair to make it a simple 2 minus 5 in the denominator. So let me just copy it first. The denominator becomes 2 minus 5, right? And for the numerator, it becomes cube root of 2 minus cube root of 5. Since the denominator is negative 3, so let me just put the negative into the numerator, and I flip the order. So I believe you can get the idea how it becomes like this. So this is the simplest form. Why? Because we have fulfill of the 3 requirements, and one of them is no radicals in the denominator. So the last one is the special one. Okay, if we have this kind of form, okay, we can simplify it still. So I will give you 3 examples. Let me show you that it has to be exactly the same form like the 2 above. So for the first example, we can relate with the form above, because it is 4 plus 2 square root of 3. So the thing is, we need to find what pairs, if you sum it, it becomes 4, and if you multiply it, it becomes 3. The pairs is 1 and 3. So you can simplify it as square root of 1 plus square root of 3, which is 1 plus square root of 3. Okay, so let me go to the second example. The second example is not exactly the expected form, because there are 6 here. So I need to convert into 2. Okay, so how? Let me just put it this way, 11 plus 6 is 2 times 3 times square root of 2. So I need to convert 3 into radical number, into radical form. So 2 times square root of 9. Square root of 9 is 3, right? Times square root of 2. So in the end, I have square root of 11 plus 2 times square root of 18. Now, this is exactly the form expected, just like the two forms above. So now we have to find the pairs that if I multiply it becomes 18, and I sum it becomes 11. Now this is the pairs, square root of 2 plus square root of 9. If I simplify it, it becomes square root of 2 plus 3. The last one, let me just convert again because it is not the expected form, so we need to convert into 2 times 4 times square root of 15. So 4 is square root of 16, so let me just put it that way. 32 minus 2 times square root of 16 times square root of 15. And let me just multiply square root of 16 is multiplied by square root of 15 is 32 minus 2 times square root of 16, 15. It's 240. Yes, it's 240. Okay, so keep in mind that we need to find the pairs. If you multiply it becomes 240. If you sum it, it becomes 32. And it has to be subtractions in between. So it will be square root of 20 minus square root of 12. Okay, it becomes square root of, and we can still simplify it. It becomes 2 square root of 5 minus 2 square root of 3. Remember, if you have subtraction, you have to start with the bigger one first, because the result, the difference must be positive. And that's how you do the special case like this one. Thank you for listening.